Good morning. So, third grade, and our program this year is every week we have a question, a science question. You see, science is based upon questions and then trying to find out the answer. And sometimes you use different science methods. But science is more than just using instruments or tools. It's really about answering the question. So if you have different questions, you use different methods. And so today, does anybody know what our question is today? Our science question for the whole week is, I'm sure your teachers have shared this with you, how does science answer questions with the design process? The design process. You've probably never heard of the design process, have you? Well, I tell you what, you use the design process, the benefits every day. For example, somebody designed these glasses I'm wearing. Can you imagine if they made glasses that were like that? No. The seat you're sitting in, someone designed it, and they made the bottom nice and smooth. I would hate it if the bottom of my chair was all bumpy and rough. Even how tall this desk is, someone designed it. This cart this young man's pushing, someone designed it. So design is when you look at a problem and you try to find a solution to it. The scissors you use today, what if those scissors weighed 10 pounds? Wouldn't your fingers get really sore? Or what if you went to cut something and they broke? So almost everything you use or everything that is in your house, any artifact, has been designed for a use. But it doesn't always work out that way. Does anybody know, it was one of our vocabulary words, what is it called when you make something to test it? Anybody? What do you think? Have you heard the word prototype? Prototype. Well, we're going to make some prototypes today. See, I'm going to show you really quickly what we're going to make. We're going to make 4 things. And the first thing we're going to make is, oh, it's real hard. We're going to make a crumpled paper. We're also going to make a small little, looks like a shoebox lid. And we're going to test these. We're going to test these by dropping them. And then we're going to make a gyrocopter. And we're going to test it by dropping it. And then you're going to make a parachute. And we're going to test it by dropping it. You see, in your books on page 46, then after we do all this prototype, you will design and make your own parachute. Okay, you ready to get started? Okay. All right, Alejandra has taken her paper and cut it in 2 parts. Hold it up, Alejandra. Now, here's my question. Are these parts the same size?
No.
They're not? Are they the same size? Oh, yours aren't. So we need to cut them so they're the same size. You cut on the line, right? That's okay. Go ahead and let's go ahead and fix that and cut them the same size. So, Alejandra, you have 2 pieces of paper, right? You cut it in half.
Yeah.
Hold them up so we can see. Are they still paper? Yes. Are they the same size?
Yes.
Hold them up so everybody can see. They're the same size. Are they the same shape?
Yep.
What do we call something in math that's the same size and the same shape? Yes.
Congruent.
Congruent. Excellent. So we're going to do a science test. And when you do a science test, you want it to be fair. Would it be fair if she used 1 big piece of paper and 1 small piece of paper? Would that be a fair test? No. So, would it be fair if she used cardboard in one hand and paper in the other? Would that be a fair test? No. So, you guys have done a very good, fair test. Now, one of those I want you to crumple up. Go ahead and crumple it up. The one that's blank. Crumple it up. Just one of them. Okay. All right. May I have your attention. Alejandra, hold it up. Hold the other paper up. Here's a hard question. Here's a hard question. Are they still paper? Are they still paper?
Yes.
Are they the same shape now?
No.
Oh, but are they the same weight? Did you add anything to them, or are they the same weight?
No.
Yes, they are. They're still the same way. So let's do one more thing. Okay, Austin, now the shape, one of them looks like what?
Square.
A square. And what's the other one look like?
A ball.
All right, let's hold them up over your head. Let's see, you're going to drop one. Now he's going to drop them. Would it be a fair test if you show me one high and one low? Would that be a fair test if he did that?
No.
All right, switch them. Make the other one. Would that be a fair test if he did that? No. Okay, what about this? What if you dropped, on the count of 3, drop the paper ball, and then drop the other one in 3 seconds. 1, 2, 3, drop the paper. 1, 2, 3. Would that be a fair test if you dropped them at a different time? What would be a fair test, Austin?
A fair test would be like both drop them at the same time.
From the same height. You got that? How many drop tests are we going to do on this?
5.
Well, how do you know it's going to do 5?
It's on the paper.
On the paper, right? It says 5 drop tests, right? Okay, so you're going to do 5 of these, and they should be a fair test. If the first one, if the paper ball hits, well, let's write the letter F, okay, for first. And if the shoebox lid is first, write F by it. If it's last, what do you think you're going to write, Austin?
L.
L. So you're going to write F or L. 1, 2, 3, drop. Record your results. Record your results.
Paper ball.
Oh, Mr. Crossland. Say that again, Adrian.
It holds the air on the top of it.
It catches the air on the top of it?
Yeah.
All right. Okay, Trinity, show us what you have. This is called a gyrocopter, Trinity. And I want you to hold it by the top. On the count of 3, drop it, and let's see what happens. 1, 2. Oh, it didn't do very much, did it? Try that again. Turn it around the other way, and let's drop it like this. Hold it from right here. 1, 2, 3, drop. What can we do to make that drop better? Why don't you fold one of these down, and fold the other one the other way. Okay, now hold it, and let's drop it from real high and see what happens. 1, 3, drop. Okay, so these 2 classes have made gyrocopters. They're learning about how things move through air. Ready? 1, 2, 3, drop. Wow. Now, can you change it to make it drop faster? What would you do to make it drop faster? Change it. Show me. So it drops faster. What did you do? Oh, you took off the paper clip. Oh, you bended yours down more. Oh, you made yours look like that. All right, let's test them faster. Ready? See if they go faster. 1, 2, 3, drop. Did they go faster? Now, can you make them go slower? What would you do to make them go slower? You have 3 seconds to make a change, to make it go slower. Ready? 1, 2, 3, and drop. Wow. Okay, I would like you to think about, with a partner, what have you learned from this gyroscopic?
I learned that this cuts air and this like gets air on the bottom, so it spins.
5 seconds. Ready? Stop talking. Go. Okay, so these folded lines, I don't care if you put the dot lines on the outside. So you fold, that's the tab. When I designed this, I practiced once. Okay, there's a tab. I like how you're watching, and there's another fold, and there's another fold. And now, this is like a pyramid. It fits together. Hand me a piece of your tape. Hand me a piece of tape. Thank you. Thank you. And so you fold it on the dotted lines and just use one piece of tape. One. Okay? Cool. So why do you think Leonardo da Vinci made his in this shape? What's he trying to do on a parachute? What's he trying to catch?
Air.
Air. Do you think it would be better to go this way or this way?
The other way.
Why? Okay, but now mine flip-flop, so now we need to add some strings. You see your strings? Okay? And scissors. Okay, have the tape ready. First thing you do, this string is way long, but that's okay. Scissors. That's, yeah, okay, so you need 2 strings. I might even say these are too long, so I'm going to use about, you need 2 strings about this size. Yes, yes? Yes. Hand me a piece of tape. Have tape ready. And now there's a bunch of ways to do this. We're going to do it my way. Okay, first of all, I like to take the tape on the string first. Give me that piece of tape. And then I put it right here like this. Yes, yes? Yes, yes. Now, you can do it different ways. Tape. Tape. Scalpel. Stethoscope. We're going to lose the patient. Hey, look, tape it on the bottom here first. Yes, yes. And then, you know, I like to do it consecutive, which means around. You could crisscross, but it's better if you do this. Next, tape, please. Tape. Well, look at this, man. He's fast. We want to have this operation to go well. Where should I put this one? Right here. Okay, good, good. Tape. And I like to tape it first. And then bring it up. And now, wow, look at this, check it out. Oh, got to put my name on there. Leonardo da Vinci, no, that's his name. And put your name on it, and then put a paper clip here. What are you waiting for? Go make your Leonardo da Vinci parachutes. Okay, so now you've made your 4th object to do a drop test with. And you'll see on your worksheet, right here, the one that shows Leonardo da Vinci, there are some drop tests. First you do it 1 paper clip, and you do 3. So you might do that with a partner. Do you think that adding more weight will affect how it drops? Yes or no? Yes. I don't know. You're going to find out. Do you think that it will drop faster or slower or the same by adding more paper clips? The other thing I want you to do is, when you're done, what would happen if you cut a hole in the top to let air out? Would that make it go faster or slower? So when you get back to the room, you have made 4 prototypes. You have tested each one of them, and you've learned some information that might help you build a better parachute. So in your book on page 48, after you do this and write about it and talk about it, you can do the activity that says, how can you build a parachute? This is where you say thank you and clap really loud.
Thank you.
And thank you for being such good science and teachers. You guys are awesome. I have everything prepared. Makes the job